Hello and welcome to Amit's Tech Sessions. My name is Amit and I'm a software architect. In this video, I'm going to cover some fundamentals of containers and Dockers. And along with that, I will also demonstrate how you can containerize a simple Spring Boot application and then execute that Spring Boot application in the container. So let's start. So what are containers? Before I talk about containers, let me tell you a little story about my career. So when I started my career long back, I joined a project where we were building Java applications. We were deploying those Java applications directly onto the physical servers. Then there came an evolution, and we started getting virtual machines for application deployment. So all the Java applications which we had, then we started deploying them onto virtual machines. So in today's world, containers and serverless are quite popular. Containers became popular after the virtual machines, and serverless is currently popular as well, but they both have their own use cases. So what are containers? I generally explain the analogy of containers using a pizza box. Let's say you go to a supermarket and buy a box of raw material to prepare a pizza, right? So this box comes with everything inside, what you need to bake that pizza. This can include like pizza base, toppings, any cheese, any other sauce, any flakes, or anything else you need for that pizza. So similarly, containers include everything what you need for your application to run. For example, application code, dependencies of the application, any configuration required by the application, and also the runtime required for that application. So, and these containers are self-contained units. As I said earlier, virtual machines were popular before containers came into the world. So it is important to understand the difference between virtual machines and containers. Virtual machines use the virtualization technology. They use hypervisor from your physical machine, and then this hypervisor is used to create those virtual machines. Each virtual machine runs its own guest operating system separately from the other virtual machine, even when they are running all on the same host, which actually makes these virtual machines heavyweight compared to the containers. So, on the other hand, containers are further up the stack. They are an abstraction at the app layer that packages the code and dependencies together. Multiple containers, they can run on the same machine and they share the operating system kernel with other containers. But containers run in their own isolated processes in the user space. And containers generally take the less space than the virtual machines. So these are some of the differences between containers and virtual machines. What are the benefits we get out of the containers? So we get portability. So containers are highly portable and they can run on any server, cloud provider, or local environment without any issues. We get high degree of efficiency from the containers. Containers are lightweight and they consume fewer resources compared to the traditional virtual machines. So this makes them perfect for deploying applications at scale. Isolation. So containers are isolated from each other, which helps in avoiding the conflicts between different applications. We get consistency. So containers ensure that the application runs in the same environment regardless of where it is deployed. This eliminates the risk of any unexpected behavior due to environmental differences, which we used to have in the world of virtual machines. And the last but not the least, fast deployment. So containers enable the fast deployment of the applications as they can easily be created, started, and stopped within seconds. This fast deployment also enables your product or application speed to market. Now I'll talk about Docker. So what is Docker? Docker is a container engine. So it provides you the ability to package and run an application in a container. It provides the tooling to manage the life cycle of the container. So we understood container, right? Now what is Docker? So Docker, what it does is it gives you a container platform or container tooling which helps you to package your application within a container. And there are a couple of concepts which you need to understand from the basics point of view. So Docker image, right? What is Docker image? Docker image, it contains your application code, libraries, tools, dependencies, and other files which are needed to make your application run. Right? And there's another concept called Docker file. So Docker file is a text document that contains all the instructions uh, which are required to build that container image. So we will see this in demo as well. The Docker file we will also see in the demo. So we are going to go to a demo of containerizing a Spring Boot application and how it will look like. Have a Spring Boot application which I am going to show you, and then I will have a Docker file, and using that Docker file, I will run a command called docker build, and that command will create an image. Then we will start that container from that image by using a command called docker run, and then we are going to test our application. Is it running inside that container? So this is the Docker desktop which I have installed on my Mac machine, and this is the home screen of Docker desktop, which displays what are the containers running here. Currently, I don't have any containers running. There is a images option in the left navigation, so you can find your local images which are running in Docker, and you can also see some remote repositories which are connected with the Docker. You can also find out volumes here. Uh, so in Docker, you have a concept of volume. You can attach volumes to your container, and there are some environments option as well. This is Docker Desktop for Mac, but if you're running on Windows or any other operating system, you can install Docker accordingly as per the instructions. Now we are going to see my Spring Boot application. So this is my Spring Boot application. It is written in Java 8, which is an older version of Java, but we are not focusing on Java versions here. We are only focusing on the concept of containerization. So this application has a main file, main Java class, which actually runs the Spring Boot application, starts the Tomcat server. Then there's a controller, employee controller, which does have a bunch of endpoints to deal with the employee operations. So it mostly does the CRUD operations on the employees. So now I'm going to run a command called mvn clean install, which will create a Java artifact, which is jar file, into a target directory. So that command is now done, and we can see here the target directory is created. So this target directory has this jar file created. Now I'm going to run a command mvn spring boot run to start this application, just to test it out that it is running on our local host machine. So Spring Boot comes with a default Tomcat server, and you can see the Tomcat is started on 8081 port. Let's go to the browser and see if our application is working as expected. So I have an endpoint called show employees, so I'll use that, and application is working as expected. It is giving me the employees list along with some of their data. Now, now our task is to containerize this application and then run this application from that container. And as I said earlier, to containerize this application, we need a Docker file. I already have a Docker file created, and this Docker file does contain 4 lines. So the first line is pulling the base image of OpenJDK 8 because we need Java runtime for this container. The second line is defining an argument named jar file and referencing to the target directory jar file in our local root directory of the project. The third line is copying that jar file into the container itself with the name springboot_swagger.jar file. And the last line is the entry point, which is actually running this jar file in the container, java-jar springboot_swagger.jar. So now we are going to containerize using this Docker file. So the command which I'm going to execute is docker build in the current directory dot -t and then name of the image which will be created. So I'll put a name Spring Boot Swagger, and I will run this command. This will create a Docker image. So the image is created. We can verify that image is created by running command docker images. We can see Spring Boot Swagger image is created. It has tag, image ID, and the metadata including created and size. Now we are going to run this container. So we will run docker run, and we will give the image name Spring Boot Swagger. So this has started the Tomcat again on port 8081. So we will now go to the browser and verify that this is running or not. So this is not running. Now the reason for this not running is because your port 8081 is running inside the container, not on the host machine, and this browser is on my host machine. So there is a mechanism to forward that port from container onto the host machine. So I would actually run a command which will forward that port 8081 to a port 8081 in the host machine. So we'll use the same docker run command, but there is just an argument which you need to define with that docker run command. So let's do that. So docker run -p, which is for port, and then container port 881 will be forwarded to the port 881 on the host machine, and then the image name. So it is starting the server, and as we can see, again the Tomcat started on port 881 in the container, but now it will be visible on the host machine as well. So we can see the list of employees along with their data. So in my coming videos, I will be talking about containers on AWS, including some hands-on demos. I'll be starting a Kubernetes series, including some hands-on demos, and I will also do some hands-on demos on the AWS cloud services. That's all. If you like my content, you can scan those QR codes up on the screen. You can connect with me on LinkedIn and or Medium. Thank you.